Hello, and welcome to the next example. So this is where we're going to be diving into different problems related to actually comparing prices. And this is going to look a very different than what you're used to, most likely. We're going to talk a little bit about this in class, but I just want to make sure that we have the checkpoints along the way. So I'm going to pause the video, and I would recommend that while you also pause the video, that you make sure that your annotations and that your setup of part A are completed. Then when you unpause the video, those should be shown to you. Okay, so go ahead and take a look at what I have here. The boxes that I put in orange are the ones that I highlighted or annotated. Sorry, I almost blended the two words. You should have the ounces highlighted with yellow and the dollars highlighted with green. You should have also noticed that the first ounce is combined with the first dollar amount in a ratio. But the ratio is dollars to ounces, not the other way around. And so when you write ratio A, the first ratio, it should be $2.79 to 10 ounces. And then for ratio B, you should have seen that the 13-ounce box costs $3.99. And so the ratio is $3.99 to 13 ounces. Once again, I'm going to ask you to pause the video and attempt to set up the rates. You don't need to completely finish all of part B, but try to get as much done as you can before you unpause the video. All right, so once again, I hope that you were able to set up at least as much as what I was, maybe a little bit more, maybe a little bit less. So what I've done so far is I filled in the first fraction for ratio A and the second first fraction with ratio B. So the dollar amount on top and the ounces on the bottom for each. I also wrote down the rate, but I don't know what the rate is yet. I just know what the words are, dollars per ounce. And I know that the calculations above, the fractions, are going to help me to find that because they both have a fraction that's on top of 1 ounce. So we see that here for ratio A and here for ratio B, where something out of or over 1 ounce. So now we need to figure out what to calculate and how to do that. So I need the 10 to become a 1. So what would I need to divide by? Hopefully you thought of 10. You need to divide a number by itself to get a 1. So this would have to be 10. And whatever I use on the bottom has to be used on the top. Over here, whatever I divide by has to make it a 1. So it has to be the same number as what's on the bottom, 13. And whatever I do on the bottom, I have to do on the top. Now here's something that might seem kind of confusing, but is pretty cool. You might be able to use a calculator on a phone or on the computer, or if you actually have a handheld calculator, you could use that to do the calculation on the top. But what you're not going to get is an approximation. You're going to get as many digits as are applicable when you do the long division. And dividing by 10 is not a problem, but dividing by 13 gets you some pretty strange decimals. It just keeps going and going most of the time. And so what I've done is I've created a digital calculator. This is basically like our slide version of a calculator, but we have to be careful about what we do. So I'm going to look for the calculation that's relevant. I see that I want to divide 2.79 by 10. And so that's this first one right here. Oops, sorry. So this one right here tells me that if I divide 2.79 by 10, I'm going to get 0.279. Notice it became smaller. That's good. It should be getting smaller from the original. Basically what happened when I divided by 10 was the decimal moved. And now the 2 is behind the decimal in the dime place instead of the dollar place. But most of our money is not counted on the third decimal place. It's only counted to 2. And so you'll see that I said approximately equal to 0.28. And that's because if you have a 9 as your next place value, that's so close to being the next place value that you can basically say that that's approximately the same thing as 2.8 instead of 2.7. And that's because 9 is more than halfway to the next number. So it's approximately $0.28 per ounce. And so that's what I'm going to put here, $0.28. And then here, $0.28 per ounce. In other words, 28 cents. For every ounce that you buy of this cereal, you have to pay 28 cents. So $0.28 for every ounce of that particular box of cereal. Now we're going to do the same thing for this one. We're going to look for this calculation, 3.99 divided by 13. So I see 3.99, the bottom two, and I see one of them is divided by 10, which I don't want. I want to make sure I'm dividing by the correct number. That's 13. Now this is interesting. It says approximately equal to at the beginning, and that's because I had to actually cut it off because it kept going forever. So 0.3069, and then it kept going. So I had to stop it. And I said, well, for money, I only care about 2 digits after the decimal. We call that the hundredths place. So there's the tenths and then the hundredths. So the hundredths place is currently a 0, but since the next number is bigger than 5, it's approximately a 1. So $0.31 per ounce, $0.31 over 1 ounce. All right, I'm going to pause the video and I want you to fill in your notes and then also complete part C. Okay, so hopefully you took some time to make sure that your notes were up to date on part B and part A. And in part C, I went ahead and I copied the sentence stem. It says Marilyn should buy the blank box because ... So which one should she buy? Well, according to the unit rates, it looks like she's going to spend more cents or more dollars if she buys the second box, even though it's a bigger box, which usually means that you're actually saving money. This one actually is not saving money. So maybe there was a deal on the 10-ounce box that cut it even further. It was maybe on sale because you're only paying 28 cents for every ounce, whereas this one you're paying 31 cents. And so this should say the 10-ounce box, and then you can explain why. The second part of this is we need to figure out how much different they are from each other. And so when we're talking about the difference between the unit prices, we're looking at the 0.28 and the 0.31. And the word difference in math means the answer to subtraction. When I say difference in math, I don't mean, oh, this one has a like reddish hair and this person has like blonde hair and this person has darker hair. That's not what difference means in math. Difference in math means how far off are they from each other. So how far off two things are from each other is what you would get when you subtract them. Like if I say, what's the difference between my height and Mr. Caesar's height? What I would do is compare our heights and I would see, okay, well, I'm going to subtract my height and his height and see how far off we are from each other. And that would be the difference between our heights. So here we're going to find the difference between the two different unit rates. I'm going to pause, and I'd like you to pause as well so that you can set up the subtraction and see if you're on the right track. All right, so hopefully you paused and you were able to set up the subtraction, which is 0.31 on top of 0.28. You cannot have it switched. If you have it switched, then you're basically finding a negative answer. You can't subtract 31 from 28. You can only subtract the smaller number from the bigger number. And so the 31 has to be on the top and the 28 on the bottom. And then when I subtract, I need to, in my head, regroup because 1 cannot take away 8. So the 1 can become an 11. The 3 becomes a 2. 11 take away 8 is 3. And 2 take away 2 is 0. And so this shows 0.03. In other words, 3 cents. For every ounce that you buy of the cereal, you're paying an extra 3 cents for the 13-ounce box compared to what you're paying for the 10-ounce box, every single ounce. So that means for the 10-ounce box, you're saving 30 cents. 3 cents for every ounce. So 30 cents total is being saved if you were to buy a 10-ounce box for that price versus a 10-ounce box with like the type of price that this other one has. So you can copy and paste from the sentence stems down at the bottom, and you can say that the difference is $0.03 per ounce. All right, I'm going to pause the video, and I look forward to working with you some more in class. Hopefully this was helpful.